Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are still going to look at, SURDS. So we are still on the topic, SURDS. And, in our previous meeting, you realized that we're looking at what? Core math aspects of what? Of SURDS. And in our previous meeting, you realize that this was the assignment that was given. So quickly we'll look at what I walk you through the solution and what was expected of you. Then after that, we'll move on to what we are supposed to actually do today. So quickly, let's go and have a look at what the solution. And I'll address some of the concerns, especially the major ones. However, after that, if you still have any concern that you think I have not addressed particular, please, don't hesitate to let me know. So, when you read question here, the first thing that you come and write is solution. After underlining the salient part, if any, there is no salient part. You were just asked to simplify. So you extract. And remember, here we are dealing with division. And the first information that I gave you, in terms of solving questions on SURD involving division, is, try and use that concept that root of A over root of B is equal to root of the whole of A over B. So here we'll extend the denominator, and I told you, that if you write it this way, which some of you did and I marked you down, this is supposed to be equal to root of the whole of the numerator and the denominator. This must cover your denominator as well. So if I realize that this is not covering your denominator, and you think we are supposed to take it like it's covering what the denominator, I've told you, you lie bad. We will not think that way. You only mark what we see, not what you think or what you have in your head, or what your thought was. So in this case, if you don't extend it to the denominator, it will be M0, A0. So at this point, 8 will go into 24. And how many times? 3 times. So you end up getting root of 3. At that point, that will be your final answer. So you can draw your conclusion there. Or you write it and later come and draw your conclusion. And again, some of you are not, drawing your conclusion. As for the giving, I've told you, you can choose not to write. But your conclusion is not a choice. You are supposed to make sure, you conclude, especially if what you have there, what you are given to simplify is not lengthy, just like this. So B, what do we do is the same thing, only that you check. I've told, even with the A, I told you, I gave you a basic way, another way of dealing with it. That's a basic advice. There's an alternative way, basically, but this will be the ideal way. The alternative way will be when, I've told you, so simplify the sets straight away. So you will simplify this, meaning write this in its basic form, write that in its basic form before you move on. However, the advice again is immediately you realize that the denominator radicand is an exact factor of the numerator radicand. It is better you deal with it this way. So with this one, the denominator radicand, it's not a factor of the numerator radicand. So you cannot go that way. So we have to resort to simplifying the numerator, SURD, and the denominator as well. However, in actual fact, the denominator is not a SURD. The fact that you see a square root there doesn't make it a SURD. You remember we said SURDs are special, radical expressions where your radicand is not what? A perfect square, but here the radicand here is a perfect square. So this will give you 2, root of 25 is 5. And take me, if you come and write 2 times root of 5, it is not the same. 2 root of 25 is not the same as 2 root 5. It is rather 2 times 5. Am I clear?
Yes, please.
So if you wrote it that way and you ended up getting the answer correct, you use your calculator only to verify your answer. And your calculator confirmed that your answer is right. The fact that calculator confirmed that your answer is right doesn't mean you get the full score. You got it wrong from this point. So at that point, it will be M0. Immediately it's M0. We won't even look at your answer. It will be A0. Because at that point, you are performing magic. You perform magic because you cannot have, your denominator to be 2 roots of what? 5. And it will become 10. No, 2 roots of 5 will never become 10. So at that point, you've missed your way. So when we are marking, especially subjective question, we are too particular. We don't look at only the answer. If it's an objective question, you can get it right. And someone can even, okay, I mean, the person would not know what to do and can guess and get the answer right. Okay, so as for objective, it's not, okay, basic, I mean, a main way of what? Assessing students. Okay, I mean, fully, basically. So that will be it for the C. So take note, a particular concern address. The person didn't know why, okay, she was marked down or he was marked down. So with this one too, you can see your denominator here is not an exact factor of what your numerator. I'm talking about the radicals. So, but you can see that you have a common factor. You can go the usual route. Okay, take the square root to cover the whole of that and make sure you extend the square root. Then you have this and come and reduce. Okay, then after that, you know you cannot leave your answer this way. Your answer must be root of the numerator over the root of the denominator. Don't leave it this way. Always separate the numerator from the denominator. So in that case, ideally, this is where you should have ended based on, okay, how far I taught you. So some of you ended here, and at the normal circumstance, I'm supposed to give you the full score. But because I don't know who will be inspecting your notes, and you will not be there, okay, sometimes you'll not be there to explain. So immediately I marked you right, and the person is a math teacher, I think the person will have, okay, cast some sort of doubt on my, okay, what the intelligence, okay, or my professionalism. So in this case, what do? I gave you, okay, I put more or less, it's like just like half, not giving the full score. Because in maths, anytime you are dealing with SURD, you don't leave a fraction, okay, containing a SURD in the denominator as your final answer. And if you can't do that, what do we have to do? Okay, this is the technique. Okay, we multiply both the numerator and the denominator by the SURD in the denominator. Okay, so that's what I did here. And it ended up giving us the result that we have here. Some of you knew it, you did it, okay, fine. I marked you right. Okay, others ended here because they have not done SURD, so they didn't know what to do at that point. So they only made use of the information they knew, okay, up to that particular point, and that's fine. Okay, so like I said, okay, this question is supposed to usher us into our next concept of what said that we are going to learn today. So quickly, let's go and look at that. Okay, what I mentioned there is what we call rationalizing the denominator. So anytime you have a SURD, okay, which is a fraction, and you see, okay, that fraction, a SURD in the denominator, you cannot conclude. However, if there is no SURD in the denominator, you have no issues. Your issue is that there shouldn't be a SURD in the denominator, either a monomial SURD or a binomial SURD, any form of SURD in the denominator, okay, and you leave that as your final answer, though. Okay, so quickly, let me read this. So the process of removing the square root sign in the denominator of a SURD in a fraction form is called, okay, or is termed as rationalizing the denominator. In other words, a denominator of a SURD in its fraction form is rationalized when it contains no SURD. So immediately there is no SURD in the denominator. Originally, there was a SURD in the denominator, and you remove the SURD. You know that once there is a SURD, then it means your denominator is irrational. So once you remove the SURD, then you make it rational. And that is why we call it rationalizing the denominator. Initially, it wasn't rational. Now you have what made it what? Rational. Is my point well made?
Yes, please.
Okay, very good. So you can
Yes,
read
please.
these two. These are other ways of, okay, explaining what rationalizing the denominator or rationalization of what the denominator. Okay, all right. So I'm going to move on. How do we rationalize the denominator? And we'll look at two situations, okay, or two cases or types. Okay, so quickly, let's go and look at the first one. Type 1, okay, when your denominator contains a monomial SURD. And remember we did SURDs, okay, I mean types of SURDs, I should say. And realize the monomial SURD is a SURD containing only one term. Okay, so it means here your denominator will contain only one term SURD. Okay, so if you have that situation, how do we deal with that? So to rationalize a monomial denominator set, okay, this is the first step. Multiply both the numerator and the denominator, okay, by the monomial denominator set. Okay, so you multiply both the numerator and the denominator. So in effect, the expression will be kept whole because you multiply by what? By 1. Because if I have, let me quickly throw in this. Okay, if I have A over B, and I multiply my numerator by C, and multiply the denominator also by C, have I changed this expression A over B? I haven't changed it. It's still A over B because indirectly I multiplied by 1. Okay, but it's because I have a particular target. Okay, that's why I did this. So this is just for a purpose. But once I do this, I have not changed the expression. Okay, remember I told you not to multiply or divide through expression. But you can see that here I multiplied and divided at the same time. I didn't only multiply, I didn't only divide. Okay, so take note. So if you multiply, you have to divide. If you divide, you have to multiply to keep the original expression. Okay, then after, so this with multiply both the numerator, I've said it, or a set that will, and take note of the second part, or a set that will result in the radical expression in the denominator becoming a perfect square. So your purpose is to remove the radical sign. Okay, so sometimes you have to zoom into what is bringing what or making what you have there a set. Okay, where you have your radical sign, you have to concentrate on that and you will get there. Okay, I will give you how to, or tell you exactly what to do in that situation. Okay, then after that, after you multiply both the numerator and the denominator by this your monomial set in the denominator, okay, what do? You simplify the results if necessary. So quickly, let's go and look at what the following worked example. It's not difficult. Okay, so it's not difficult. So you know exactly what goes on inside your calculator to give you the results of this. Okay, so let's look at, so rationalize the denominator of the following. Okay, so you could just say rationalize the following. And you should know that here is the denominator that we need to what? Rationalize. That's not to say that it is only the denominator that we can rationalize. We can also rationalize the numerator. Take notes. And we'll do that going forward when we are doing calculus. But for now, in terms of set, usually you rationalize the denominator. So let's go and look at how best to deal with what we have there. So after reading the question, what are you supposed to do? Rationalize. Even if you were not told to rationalize and you were asked to simplify, you know, this you can't leave it in its what? In this form because there is a set in the denominator. So let's quickly go and look at what we are supposed to do. So question 1A, you know, questions are numbered because we equally want you to number your solution. I've told you, if you want to, this, please don't write solution and you come and write, or even you write on top, rationalize the denominator of the following, then solution without writing the whole of this. If you want to write a question, I've told you, write the whole of what you have here before you come and write your solution. Otherwise, the question is not necessary. I've told you. If you write it, capture only the solution part for me. I'm only interested in the solution part. Okay, as for the question I gave you, so I have the question. Okay, so now what do we have? You extract what we are giving. You can choose not to write giving, but you extract what is there. So this will be 3 over root of what? Root of 2. Okay, now what we have there is a fraction. It contains a set in the denominator. So you have to subject this one to, okay, the type 1. Okay, so that will be equal to the steps. We said multiply both the numerator and the denominator by the set in the denominator. That's your monomial set. So please take note. You don't multiply here. You move a step further. You write it again before you do that multiplication. Those of you who rationalize that and you did the multiplication at that point in the previous example, the assignment, okay, you can see that I will put an exclamation mark there, meaning that's not the point that you are supposed to do your multiplication and division by the set. You need to move a step, okay, further, okay, or ahead, so one step. So in this case, it will be root of 2 over root of 2. Okay, so in effect, we are multiplying by 1. So this is what you are supposed to do. You know the numerators will multiply, the denominators will multiply. The numerator will multiply this and give you 3 roots of what? 2. The denominator will multiply and give you root of 2. Do you agree? My professors, are you with me? Okay, so remember the steps. We said multiply both the numerator and the denominator of your original expression, what you are given, by the said in the denominator. What's the said in the denominator?
2.
Okay, so it did say 2?
Root 2.
It's root 2. Okay, so this will be your numerator times root 2. Okay, then your denominator times 2. So it will be like over, because you can't leave it hanging. You get it? So you have to bring this your bar for us to know that you are multiplying this by that. You are multiplying this by that. You get it?
Yes, sir.
So it means indirectly you are multiplying by 1. So you've not changed the expression here. Only that this to achieve a particular purpose. So what do we do after multiplying? That's step 1. You simplify, okay, if necessary. So in this case, you know, if you are given any 2 fractions to multiply, what do? Okay, numerators will multiply, denominators will multiply. Here, don't cancel. If you cancel, you go back to square 1. Okay, so just multiply. So at this point, we are going to get what? 3 roots of, so that's what I've stated here. This time, this will give you this root of 2 times root of 2. You know where we are coming. Our algebra in terms of multiplication is fine. Okay, so this gives us root of 2 squared. Someone can write 2 going forward. So in this case, we are going to write 3 root of 2 for your numerator over root of 2 squared in your denominator will give you 2. Is that clear? Okay, so here you can see that there is no, okay, said in the denominator. By multiplying the numerator and the denominator by the denominator said of the question or of the expression. So take note. In that case, I have removed. So here, because my fraction contains no said in the denominator, I can conclude with it. But before you conclude, check whether the non-radicals can reduce. Remember, division. But here you can reduce, so you can draw your conclusion. Therefore, okay, 3 over root of 2, okay, will be equal to 3 root 2 over what 2? Or someone can write 3 over 2 root 2 is the same thing. Is that clear? Okay, Prof. Leonard.
Sir, please, the second step.
Okay.
The 3 over root 2 times root 2. When you get the 3 root 2, can you make it 3 root 2 over?
Is it this one?
No, the other one.
This one.
This one.
Okay.
Yes.
But when you were reading it,
can you make it root 4?
Which one?
That one. Can you make it root 4?
Which one?
Yes.
Which one? Is it the numerator or the denominator?
The denominator, sorry.
Okay, so you want to tell me that, let me get you right. Root of 2 squared is equal to what? You want to say that, can you make it root of 4? Is that what you are saying?
Yes.
Yes, you can do that.
Yes, please.
I told you this special situation. Okay, I told you that just like if you have x times x, you write x squared. You get it? When we were doing the algebra, I told you that you can equally write this, but because it's a special situation, a set multiplying itself will give you a set, okay, to the power 2 or squared, that's all. So it's better you write it towards this way. And all along, you can see that I never did this. After the point that I gave you that information that you can choose not to do this. So anytime you see any quantity multiplying itself twice, look at the quantity squared, as simple as that.
Okay, sir.
Okay, a special situation. You are welcome. Okay, so now let's move on to, okay, the B. Maybe I will do up to C, then ask you to continue from there. Okay, so B. Okay, what are we giving? We are giving, okay, again, I don't want to write the giving. Okay, we are giving 2 roots of 2, and you leave a space, you know, a line. When you are moving from a sub question to another sub question, you know this over, okay, root of 3. Okay, so the same thing. Okay, I don't multiply here. I have to move a step. My first step is to multiply both the numerator and the denominator by the said in the denominator. So it will be times root of 3 over root of 3. Oops. Over root of 3. So if I move on, I'm going to get, now this will be equal to, numerators will multiply, denominators will multiply. So this will give me 2 times 1, which is 2, then root of 6. Is that clear? Are you with me? Okay, so our algebra is strong now. Okay, so then, okay, over root of 3 times root of 3. So, Prof. Leonard, what will we write?
Root of 3 squared.
Root of 3 squared. And please, that is not to say if you write root of 4, we will mark you down. No. Okay, only that you disclose your immaturity in maths. Okay, or you bring your immaturity in math to bear. That's all. But that's okay. You can write it. You are right. In that case, you still end up getting okay 3. So if you write root of 9 here, you end up getting 3. Okay, we'll mark you down. Take note. Okay, so now this is it. Okay, at this point, we are going to get 2 root of 6 all over root of 3 squared. We know will give us what 3, and this we cannot reduce. Okay, please, the non-radicals will divide and the radicals will divide. But we only have, okay, 2 non-radical, but they can't divide. So at this point, what do? We are going to get what? Okay, therefore, your 2 root 2 over 3, okay, over root 3, forgive me, will be equal to 2 root 6. Okay, over, and let's make sure it covers over what? Over 3. Okay, and you feed your calculator with that. You see that your calculator will give you the same result. Okay, so this is exactly what goes on inside the calculator before the calculator will throw this answer at you. Any questions at this point before we move on to the next one?
Please, the 6 in the square root. Can't you like break it down?
Okay, if you break it down, okay, why are you breaking it down? Okay, anytime a thought comes to mind, and it means there is something behind that thought. That's what I want to know. That's all.
Please, I listen because like there's 6, maybe you can have like 2 times 3 so that like you reduce it or something.
Okay, you can see that this is not a SURD. Okay, this is not a radicand. So even if you write it that way, this cannot cancel anything there.
Okay, thank you.
You get it? And I've also told you, okay, that before you think about that, okay, in that case, if you are doing that, then it means, okay, you are writing the SURD in its basic form, but the SURD is already in its basic form because it doesn't contain, also you are, yes, it's already in its basic form because it doesn't contain any perfect square apart from 1 as its factor. So it's already, once it's already in its simplified or basic form, don't stress yourself to write it in any other form. You get it? Okay, great. So now let's look at that of the C. Okay, so C, what are we giving? We are giving root of 3 over what? Over 2 root of 6. Okay, so this will be equal to, so what do we multiply the numerator and the denominator by? You put up your hand, I call you. Okay, so you write it again. So let me write it again. You know, okay, before you think about what you need to multiply the numerator and the denominator by. Okay, here, you put up your hand, I call you, and you tell me what you will do. Okay, Prof. Paulette Paris.
Please, by root of 6.
By root of 6. Okay, please, do you agree?
Yes, please.
Okay.
Yes.
Any objections?
I thought about it.
Any objections? Okay, great. Okay, so that is, someone said 2 root of 6. Okay, there is nothing wrong with that. Okay, remember, in my introduction, I said this and I told you that it would be necessary at a point. So let me go back a little. So I said, multiply both the numerator and the denominator by the monomial SURD. Okay, that is the denominator SURD. So the exact denominator SURD, that's what you multiply. Okay, or a SURD that will result in the radical expression in the denominator becoming a perfect square. So in this case, okay, the one who said, okay, let me move on. The one who said 2 root of 6, you are not wrong. You use the first part of the statement. Multiply both the numerator and the denominator by the denominator. Okay, so in that case, you write the denominator is 2 root of 6. However, please take note, what is making this, okay, irrational is the root of 6. So you can concentrate on only the root of 6, and that would be the ideal way. That's not to say if you multiply by 2 root of 6 will mark you down. You know, whenever I say ideal, you know I'm talking about what will bring in less, writing and less space being consumed. That's all. But if you choose to go that way, you will still get there. So we'll do the 2. Okay, then after that, we will decide together. Okay, so if you decide together and you think the other one, okay, I mean, you like it better, okay, and you want to go by that, no issues, go by that. Okay, because usually it's better to play it safe than to force yourself to mature and get it wrong. But only that, like I always said, I will plead, if you can adapt, because it will save you time. Okay, all right. So now what do we have? We multiply, I'm going to go by this, the root of 6 1. So multiply numerator and the denominator by, okay, root of 6. Okay, and that's what we have there. So in this case, we are going to get root of 3 times root of 6, which will give us root of what? 18, am I right? All over. Okay, so what will our denominator be? It will be 2 times root of 6 squared. Do you agree? Any objections? My loss. Professors, are we there?
Yes, please.
Okay, so you are fine. Can I move on?
Yes.
Yes, sir.
Okay, and please take notes. Okay, once I'm going to write here, I'm assuming, okay, I want to continue here. Okay, if I want to continue here and I want to take this as my, okay, next page, I am compelled, and I repeat, compelled to rule a line here. If the line is not there, all that you write here will be regarded as a rough work. I know this is not the first time, this is not the second time, the third time I'm saying this. So if you do come and write here and you don't do, and I cancel it, okay, don't label me as what? As wicked. Okay, once I have told you the right thing to do, if you fail to do the right thing, I can assure you, okay, I will not fail, okay, to do what I'm supposed to do. So in this case, what do we do? So once I'm taking this as my next page, I rule a line, and you don't do that with your free hand. Okay, you use a split edge. Okay, so this will be equal to, my numerator, I can simplify because root of 18 is not in idiocy form. So that will give me root of 9 times 2. Are you with me?
Yes, please.
All over my denominator. And as you are simplifying, okay, as you are simplifying the numerator, if the denominator too, you can simplify at the same time. Don't simplify one and come and simplify the other one later. No. As you are simplifying, do that at it. So just be fair. Okay, so at this point, what do we have? The denominator now simplifies into 2. Root of 6 squared, we know will give us 6. Okay, so which in effect, the numerator gives you 3 roots of 2. All over the denominator will give you 12. Am I right? Okay, so your next step, you know, okay, the non-radicals can reduce. We've done, okay, division of sets. So where you have a set and being divided by, okay, a non-set. So 3 and 12, they have, okay, a number in common, a factor in common, which is 3. So I can reduce, but that will give me my last step. So I can do that, okay, in my conclusion. So therefore, what am I giving? Root of 3 over 2 roots of 6, okay, will be equal to, now my numerator, this will go here 1 and go here 12. So I'm going to get 1 over 12, okay, root of what? 2. Or someone can write root of 2 over 12 is the same thing. Is that clear?
Yes, sir.
Okay, so, okay, Prof. Laurentia.
Sir, please, supposed to be 1 over 4.
Very good. So it means they were not following. You get it. It cannot be 1 over 12. This will go into that. Okay. And please, when you are canceling, if possible, okay, do your cancellation or reduction mentally. Meaning maybe don't come and write this 1 and come and write here 4. It's usually not necessary. It's JHS that we allow you to do that. By SHS, you can avoid. So on that note, okay, you know what you have there is wrong. And if you use your calculator, you would have, the calculator would have given you a hint that there is something wrong. I mean, using the calculator to verify. So go back and check, but always do the right thing so that you make the calculator redundant. Okay, so what do we have over what? Over 4. Okay, so this will also be over 4. All correct now?
Yes, please.
Okay, so it means now that I know you are all fully awake, okay, let's move on to our next, question. So D, D, what do we have? Okay, so we have, let's look at the alternative method. Remember I said we'll look at the two and see which one would be ideal, then we adapt. Okay, so let me be true to my, well, so we are going to look at the alternative to that of the C. Okay, so C, alternative. Okay, so what are we giving is root of 3 over what? 2 root of 6. So you write it again before. So let me write a C here. You write it again before you multiply. Okay, so it will be times 2 root of 6 over 2 root of 6, like you said. Okay, and this gives us what? 2 root of what? 18, am I right? All over, this would be 2 times 2, which is 4. Okay, let me write it 2 root of what? 6 all squared. Okay, just for consistency's sake. Okay, so now this will be equal to, I go and simplify my numerator. So it will be 2 root of 9 times 2 all over, 2 squared, which is what? For the root of 6 squared, which will give me 6. Is that clear? Remember, we've done how to simplify this in multiplication when we're looking at multiplication. So now what do we have? We are going to get this to be equal to 2 into this now reduces to 3 root of 2 all over. Okay, and at this point, if you are smart, which I know you are, you could have even reduced before multiplying. So let's do that, that will be better. So let's do that. That's not to say if you do exactly what I'm doing, we'll mark you down, no. Okay, so take note. So on that note, I know this will cancel. Okay, so let me clear the book of this. I hope you are following my professors. Okay, so before you multiply, you can reduce because they are multiplying. This is multiplying this much. So they are factors you can reduce. Okay, so 2 will go here. So in effect, I'm going to get my numerator to be 3 root of what? 2 all over my denominator. 2 is here times this. So that will give me 12. Then I go and reduce. So you have before you, and you go and you can say that your next step will be, your last step, you draw your conclusion there. Okay, take note. Don't end here. Okay, so let me assume this my next page. Okay, I'll really do a line. I won't do. Oh, there is another question, so I will need it. I will need that space. So let me come and continue here. So assuming I want to take this side as my next page, so equal to, then I will reduce. Or at that point, I can draw my conclusion. So I draw my conclusion. So that will give me, root of, so therefore what? Root of 3 over what? 2 root of 6. Oops, make sure it covers. Okay, it's equal to your, what do you call it? 1 over 4 root of 2 or root of 2 over 4 is the same thing. Is that clear? So just look at the two and see which one consumed more space, which one, did we write more, and what have you? Okay, if you write more and you understand it, it's better. Okay, only that, please make sure if you, want to be on the safer side, you have to be a fast writer. Okay, all right, so that's it by, so let's look at what that's of the D. So D, D, what do we have? Okay, we've been given root of 5 over root of 8. Okay, what will we do? Sorry, root of 8. What are we going to do? Or what are we supposed to do? What's the first step? Hello, my professors, can you hear me? Are you there?
Yes.
Yes. What's the first step? What should be the first step?
multiply both sides by the denominator.
By root 8. Okay, no problem. Okay, that's okay. However, remember, I've told you, any set that you can reduce before going to multiply, because it will help you deal with smaller values. And anytime you are dealing with smaller values, okay, you make your calculator redundant, because picking your calculator, punching, and what have you, okay, will equally take, okay, some of your time. So I'm going to go that route. Okay, so now what do I have? I'm going to write this is equal to, okay, and that is equal to what? Keep my root of 5, come and reduce my denominator, and that will give me 4 times 2. Is that clear? So I'm going to get root of 5 over 2 root of 2. Is that clear? I write it again, then divide my, please, are you following my professors?
Yes.
Okay, so I will divide by pair what you were taught just from here. Okay, I am going for the situation where I will multiply it by only the set. I mean, I'm talking about the this particular, okay, factor here, the radical factor. So now it will be root of 2 over root of 2 instead of 2 root of 2. Okay, so that gives me root of 10, okay, as my numerator, and my denominator will give me 2 into root of 2 squared, so I now mature. That will give me 2. So in effect, I'm going to get root of 10, okay, over 4. Then I can't reduce anymore. So I come and draw my conclusion. Now I could have drawn my conclusion there. All correct?
Yes, please.
Okay, that's not to say, please, that's not to say this is the only way. Okay, so root of what? Root of 10 over 4. Even the answer, someone can write it as 1 over 4. Root of 10 is the same thing. Safa. Okay, so now we know how to rationalize, okay, where your numerator, so you can see that all the examples here, numerator, okay, denominator monomials. Okay, so let's look at, okay, our next example. Okay, so our next example, denominator, you can see that we are looking at that type 1. So all your denominators will be monomials. I'm talking about monomial set. But my numerator, okay, can be anything. Okay, is the denominator that type 1 is said is the denominator that contains a monomial set. So in this situation, your denominator, okay, contains a monomial set. However, your numerator contains a binomial. It could be, okay, a binomial set, okay, or any other. But usually it will be a binomial set. Because I cannot write, okay, 1 plus what, maybe 3 there. Because one of the terms must be a set. Other than 1 plus 3, instead of writing 1 plus 3, I have to write 4 to bring maturity to the question. Okay, so now let's move on. Okay, so we are going to get solution to question 2. Again, we need to rationalize the denominator. So A. Okay, the same concept, only that it will involve a little more work here, that's all. So 1 plus root of 3 over root of 3. Okay, so this will be equal to, write it again before we multiply. Never forget this step. And you can see that because there's an expression, each step I introduce that with equal to. Okay, so times root of 3 over root of 3. Okay, so this will be equal to, my denominator, very easy to get. So root of 3 times root of 3, now we are mature. That will give us what? 3. Okay, let me even write it root of 3 squared. Okay, just for the purposes of explanation. Okay, so now, you know, what you have here is the root of 3 is multiplying these 2 terms. Or each of the terms here will multiply the root of 3. Is that clear? Point well made, my hand. So you go back to your normal algebra. So that's why I spent time on the algebra, because I knew you. So this will give me 1 times root of 3, which is root of 3. You can see that I'm doing it mentally. I'm mature. Then plus root of 3 times root of 3, and that will give us root of 3 squared. All correct?
Yes.
Okay, and I said someone can write root of 9. Only that you let us know that you are not that matured. Okay, so now what do we know? Okay, the denominator will give you 3. Numerator will give you root of 3. Then plus root of 3 squared will also give you 3. Okay, so now you can see that your result here, there is no set in the denominator. So it means this is how far you can go. and your numerator too, you can
Sir,
combine. Yes, please.
sir, it's 3 plus, it's root
This
3
one
plus 3.
is 3. This one is not intentional. Okay, all right. Okay, suppose you, so it means you are following. Suppose root of 3. I don't know why I wrote root of 2. I'm exhibiting symptoms too early. All right, so this is it. Okay, so now how far you can go? You can combine this, okay, because they are not like terms. And this one, it doesn't contain a set. So you draw your conclusion. And as you mature, someone could have drawn the conclusion here. So the person will not lose any mark. So therefore, 1 plus root of 3 over, okay, root of 3, okay, will be equal to, okay, root of 3
Sir,
plus, yes, please.
please, can't you divide the 3 and the 3?
No,
Can't
if
you
you want
cancel
to,
out?
you can't cancel out. You know, you've gone beyond this. So you can't cancel this out because they are terms. If you cancel this out, you'll not be fair to this. Even today, I said it. If you can cancel, then they should be products. We've encountered this situation, so it means that advice is not well taken. Okay, initially, that's what you had in your mind. I've dispelled that misconception, so I don't have to see that again. You can't cancel. If you want to cancel, then you have to separate. It will be root of 3 over 3 plus 3 over 3. Then in that case, you can cancel. But if you cancel this, you've not been fair to this because this is also dividing this. If you cancel it, where will it divide? You get it? So before you cancel, check whether what you are canceling, they are all factors. So this is a term, not a factor because of the plus. However, this is a factor, so you can cancel. All correct? So you cancel at your own peril. Okay, so let me see. Someone has a message. Okay, and please, you can split. Okay, however, don't split. In every, I've said this and I'm going to repeat, in every algebraic expression, if you have more than a term, okay, where one contains a fraction, it's better you leave your answer as a single fraction. Have I said this before? I have not. Because I remember I told you that it is the single fraction form that you can see, whether you can factorize something and cancel and reduce. So always, unless otherwise stated, leave your answer as a single fraction. If you want you to split, we will tell you. The question specifically, indirectly or directly will tell you to split. However, if the question doesn't say that, please make sure you leave every set of fractions as a single fraction. Okay, take notes. Okay, so once my point is well noted, let's move on to, okay, that of the B. Okay, so B, what do we have? We have 2 minus root of 6 all over what? Root of 6. Okay, so first of all, let's check whether any of the sets, okay, is not in its basic form. This set is in its basic form. This also in its basic form. So you move straight away to your step 1. Multiply numerator, denominator by the set in the denominator. And here, okay, we are going to get 2. You write it again, please take note, over your root of 6. Okay, then times root of 6. Okay, over root of 6. All correct, my professors?
Yes,
Okay,
please.
so this will be equal to now, you know, I always write my denominator first because that will involve little or no work. Root of 6 times root of 6, and that will give me 6. Okay, I've written it there straight away. Then this is going to give me, each of the terms here will multiply root of 6. So it will be 2 times root of 6. Okay, and please take note, not only this one multiplying that. Okay, because it's a single fraction, I can choose not to put this in bracket. The meaning is the same. So it will be 2 times root of 6 to give me 2 6. Okay, then minus root 6 times root 6. So that will give me minus root 6 squared. And that is what 6. Is that clear?
Yes, please.
Okay, so you can see that now I'm bringing in a bit of maturity representation. Okay, now that I know your understanding is better, I can present it actually. Okay, because if I have skipped at a point, some of you will get confused. So as you move along, we'll be maturing. So I will introduce you to. So at this point, okay, you know, okay, in this particular instance, okay, you ask yourself whether you can end here. Can we end here? If yes, why? If no, why?
No.
Okay, why?
Because you can divide the 2 and
Very
then
good.
the
So here,
6.
very good. Because you can see, remember, because it's a single fraction. Okay, remember I told you, if you can factorize, okay, check whether the factorization is possible, and factorization will result in reduction. If factorization is possible and it will not result in reduction, I told you factorization wouldn't be necessary. So if you factorize, it won't even give you parts. So you only factorize when you know that factorization will result in simplification, in that case, reduction. So here, if I want to factorize, 2 is common. Okay, it's a factor of this, it's a factor of this one too. So I can bring out 2. And if I bring out 2, yes, the 2 will become a factor of 6, and that can cancel this, a factor of the 6. Okay, so if I factor out 2, it will result in a possible reduction. So factorization is necessary. So on that note, I'm going to write 2 out. Then I will get root of 6. Okay, then minus what? Minus 3. All over what? 6. So now this can cancel this because the 2 here is no longer a term, it's a factor. You get the point? Because if 2 had plus here, either before or after 8, okay, indicated there, then you know that it's a term. So in this case, because it's this, it will be plus after. So this I can reduce, and that will give me my final answer. So at that point, this is what I'm going to do. Let me write it so that later when you mature. So this will cancel that. So I will get root of, because the coefficient now will be 1. Okay, it's not necessary to bring the bracket. It's simply understood to be there. So root of 6 minus 3 all over my denominator will now give me 3. Because 2 will go here, okay, 1, and go here 3. But just as I just told you, you can choose not to show it. It's not necessary. Just come and show it here. Is that clear, my professors?
Yes, please.
Okay, so I could have, and we could have drawn our conclusion here. Just for some reason, I decided to write it. So therefore, what are we giving? 2 minus what? Root of 6. Okay, all over root of 6. Okay, will be equal to, now what do we have? We are going to get root of 6 minus 3 all over what? Over 3. So single fraction is the best way to go, unless otherwise stated. So that's not to say that if you split it, okay, we'll mark you down. Okay, usually we'll leave our answer in a single fraction form. So make sure you leave it in a single fraction. Okay, all right. So the rest basically will be the same. So with this one, with the C, okay, you multiply both the numerator, denominator by, you know how to. Only that this time around, when you are multiplying the numerators, you multiply sets. Okay, with this one, you multiply an unsaid and a said. Okay, then a said. But here, all your multiplication will be said times said, because it will be times root of 5 over root of 5. So it's root of 2 times root of 5, root of 3 times root of 5 in the numerator. And the denominator will give you root of 5 all square, which is 5. Afa. Or you think we should do it?
Yes, please.
Okay, so
Yes,
quickly we'll do it, no issues. Okay. All right, I'm here because of it. Okay, so now what do we have? We are giving root of 2, okay, plus root of what, 3, all over, okay, root of 5. And you wonder why you asked me to. Okay, so you write it again. Don't come and multiply here. Please take notes. Okay, so root of 2 plus root of 3 all over, okay, root of 5. Then times, okay, your root of 5 over root of 5, because that's the said monomial said in the denominator. So now I've told you immediately I'm going to multiply. I will always write my denominator first. It's usually easy. So root of 5 times root of 5, that will give you root of 25 or root of 5 squared, which is 45. Then my numerator will now be root of 2 times root of 5. So that will give me root of 10. Okay, then plus root of 3 times root of 5, and that will give you root of 15. Alpha. So you can see that it's so easy. At this point, okay, there is nothing to factor out and reduce. So you conclude with it. Therefore, this is equal to this. Safa.
Yes, please.
Okay, so let me see if I can. So therefore, okay, root of 2 plus root of 3 over root of 5 is equal to root of 10 plus root of 15 all over root of 5, also all over 5. Okay, as simple as that. Okay, so on this note, let me see whether there is, okay, a third example. Okay, all right, so there is, okay, 3. When we come back from the water break, okay, then we look at that of the 3. Already spent 1 hour. So you are welcome back from the water break. Now let's go and look at what the solution to these questions. Okay. So indirectly we are moving from, okay, simple to complex what questions. Okay, so again we are asked to simplify the following. So you can see that here you are not directly told, okay, to rationalize. Okay, but you can see a surge in the denominators, okay, in each of them. And unfortunately, you cannot, okay, leave your answers in that form, you know now. Okay, all right. So I'm reading somebody said, the B after the line, how did, okay, so how did the 3 on the second step become 3 on the second step? Oh, we've gone beyond that and you are drawing us back. Okay, so please, okay, the B here, if it is this one that you are talking about, please, okay, I'll plead with you. I can't go back, so wait for the video. It's too far, okay, because we've gone far, far beyond. Okay, so wait for the video. It is addressed there. And then you pay particular attention. Oops, okay, so now we are going to look at what the solution to these questions. So question 3. Okay, A. So we are asked to simplify anyway. There's nothing special to underline, salient in the question to underline. So 5 minus, okay, 5 over root of 3. Okay, you have 2 ways of dealing with it. One is to, okay, rationalize. Then after that, you take the single fraction because your answer must be left as a single fraction, just as you were told. Or you can take the single fraction and later rationalize. And I'm going to go that route. So I'll write it as a single fraction. So in that case, this will be regarded as over 1. My LCM will come. And at the point that I'm taking the LCM is equally a step. So I write equal to there. So my denominator will be root of 3. Okay, 1 will go into root of 3, how many times? Root of 3, then times 5. So I will get 5 root of 3 here. All correct?
Please come again.
Okay, so as for the LCM, you know, okay, you've taken a lot of LCM, it will be this 1 times this over 1. Okay, then the denominator becomes what? The root of 3. So 1 will go into root of 3, how many times? It will be root of 3, then times 5. 5 times root of 3 will give you 5 root of 3. That's a special. Is it clear now?
Yes, please.
Then minus root of 3 will go into root of 3 how many times? It will be 1 time, then times 5. So that will give you 5. Okay, so in effect, if you've taken the question to your comfort zone, you know how to deal with single fraction, which needs rationalization. So I have 5 root of 3 minus 5 all over root of 3. Remember, you write it again before you multiply. You can't multiply it there, you lose some marks. Okay, so this will be equal to, okay, now I've told you the denominator will be easy to write, root of 3 squared, and that will give us what, 3. Okay, the numerator will be 5 root of 3 times this, so that will give us 5 times 3. Because it will be 5 times root of 3 squared, or 5 root of 9, which will give us this. Then minus 5 times this, which is 5 root of 3. All correct, my professors, are you following?
Yes, please.
Okay, so the next one, I'll write my denominator, little or no input. Numerator will give you 5 times 3, which is 15, then minus 5 root of what? Root of 3. Okay, so here, you can see that the numerator, we can factor out 5. Can you see that? Can you see? 5 is common to this, it's also common to that. However, you can see that if you factor out the 5, it will not come and reduce anything. because it will be 5 into whatever quantity. This 5 and the 3, they have nothing in common. So here, though numerator is factorable, but factorization is not necessary because it will not result in any reduction. You get my point? So that's every step on the way. Think before you write what is not necessary. Okay, all right. So at this point, okay, we draw our conclusion. Therefore, okay, what we were given, which is 5 minus 5 over root of 3, will be equal to what? 15 minus 5 root of 3 all over what? Over 3. All correct. Okay.
Yes.
So we'll do maybe, I think this one will do almost everything. Okay, at a point where I need to, I'll guide you. It will do up to C, guide you to do this one. Okay, and that will be it. Okay, so the alternative approach, let me look at the alternative approach where maybe I'll do it up to a point. So that those of you, maybe if that one sits well with you and you want to go by that one, fine. So the alternative approach, what you are given here, so the odds. And please take note, okay, after writing my question number, okay, and coming to, I don't write equal to, then I write this. Take note. I've never done that. I don't know where some of you pick that from. Okay, so A, information, you pick this exactly, there is no equal to. It is not a step, it's just an information that you are picking from the question. So 5 minus 5 over root of 3. Okay, you write it again, this is your first step. So 5, that's where the equal to comes in, minus 5 over root of 3. Then this time around, you rationalize term-wise. So you don't take the LCM. It's this one that needs rationalization. So just go and rationalize that one. Okay, so that gives you 5 minus, this will give you 5 root 3. Okay, over what? Root of 3 squared, which is what? 3. So you cannot leave your answer this way. Your answer must be left as a single fraction. So you come and take the LCM. The LCM, this is over 1. The LCM will be 3. Then 3 goes here, 1 goes here, what? 3 times this. So that will give you, okay, 3 times 5, which is 15. Then minus this goes here, and that will give you 5 root of what? Root of 3. Is that clear? And that is the same as what we have. So it's also allowed. Point well made. So it's either single fraction rationalization or rationalization then single fraction. All the processes, okay, or yes, must be, okay, dealt with before you can get your file. So you come and draw your conclusion. Afa, is my point well made? Any questions at this point? Okay, all right. So if you don't have any questions, then let's move on to B. Okay, similar. Root of 3 minus 2, root of what? Root of 3. Okay, so I'm going to go this route and see. Okay, so I'm going to deal with what they said here. So I'll have root of 3 minus, okay, 2 root of what? 3. Okay, times root of 3 over root of 3. So in effect, this gives me root of 3. Then this will come and give me minus 2 root 3 over root of 3 squared, which we all know is 3. Then you come and take the LCM. You can't conclude this way. Okay, because you can't see if there is any factor that can reduce. Or this expression here, you can reduce until it ends up in the single fraction form. So this over 1. Okay, you can choose not to write it and do it. Okay, only that's just for convenience sake that you write it. So the denominator will be 3. This goes here 3 times root of 3. So I'll get 3 root of 3. Then minus this goes here 1 times this. So I'll get 2 root of 3. Okay, so at this point, my denominator is 3. Numerator like terms. Can you see that? So I can combine, and that will give me root of 3. Okay, so that's how far I can go. I draw my conclusion. Therefore, root of 3 minus 2 root of 3, okay, will be equal to root of 3 over 3. Someone can write 1 over 3 root of 3 is the same. How far? Point well made, my professors. Are you with me?
Yes, please.
Okay, great. So let's move on to the C and the D. Okay, so I told you that the D likely I will ask you to, okay, try, okay, guide you basically. So C 1 over root of 7, okay, then plus root of what? 28. So remember, first step in every set question, okay, don't be in a hurry. Check if there is any set that you can reduce first before you go and deal with all your various skills. Okay, so now we have, I know, can this be reduced? Root of 28, does it contain a perfect square apart from 1? In 28, does 28 contain a perfect square apart from 1? My professors, are you there?
Yes, sir.
Okay, so what would that be?
4.
Okay, so you keep your 1 over root of 7. Okay, but please take note, you can equally be smart because you know that this must be worked on. Okay, this particular term needs to be worked on. This also needs to be worked on because of the denominator. So you can combine the two at the same time. Okay, yeah, so in this case, I can rationalize this, okay, and come and write this in towards basic form at the same time. So I'm going to do that. That will be the matured way. So I'm working on, whilst working on this term, which will give me root of 7 times root of 7, okay, over root of 7 here. Then plus, I'm working on this one. He says it will be 4 times what?
Seven.
Okay, so 7. Okay, so don't worry. I needed to say, I need to listen to my spirit. Okay, so which I usually do. So let me see. So root of 4 times 7, is that not it? Is that it?
Yes.
Yes, sir.
Okay, so you don't see anything wrong with what I've written.
Root of 4 times
Sir,
root of 7.
And so it will be everything here. Remember, I
sir,
told
everything
you,
must cover.
yes, it must cover. Immediately you write it this way and you assume, you think we should know that this is supposed to cover this. No. Okay, I've told you in math, whatever that you write possibly will carry a meaning. So be very careful that your whatever you write there will not be ambiguous. So now what do we have? This will be equal to, it's my point well made, my professors. So don't do this.
Yes,
Don't
please.
do this in the test. Okay, and the subsequent any other assignment that will be given, either here or in school. So this will now give you 1 times root of 7, that will give you root of 7. Then root of 7 over root of 7. I mean, root of 7 times root of 7 will give you 7 because it will be root of 7 squared. Then plus, you know that this will now give you 2 root of 7. All correct. So unfortunately, we can't end here because if you end here, we wouldn't know whether you can reduce. Okay, so in this case, we have to go and, okay, take this to its single fraction form. Remember, this is over 1. So the denominator here will be 7. This goes here 1 times root of 7, so you get root of 7. Okay, then plus, this goes here, okay, 7 times this, so that will give us 14 root of 7. Is that clear?
Yes,
Yes,
please.
sir.
Okay, so at this point, we
Yes,
can
sir.
easily combine. So the denominator will be root of 7, 7, not root of 7. The numerator will be 1 root 7, so they are like terms. So that will give us 15 root of 7. All correct. So you draw your conclusion, and at this point, we could have even drawn our conclusion there. 1 over root of 7, okay, plus root of 28, okay, will be equal to what? 15 root 7 over 7. Remember, this cannot be reduced. You know, this cannot cancel anything here. This is a non-radical, this is a radical. So if there is any cancellation, it should be from these two non-radicals, but you can't reduce. So you end. All correct. Okay, so with this one, it's the same thing, only that you have 3 terms. So as you are working on this, because this is not in its basic form, and you also work on this because it's not in the basic form, you equally work on this because it contains a Z in the denominator. So you write this as root times, root of a normal times, okay, a normal, then plus 1 over root of 3 times root of 3 over root of 3. Then you get my point. Then minus. Okay, so it will basically be the same as this. Only that this time around you have one more term. So you have to make sure that all terms that are supposed to be worked on, you work on it before you take your single fraction. Is that clear?
Yes, please.
Okay, great. Okay, so on that note, okay, we are going to look at, okay, another set of questions. Okay, it's not entirely different from, but the nature of the question, we will argue differently. So how do you get the 14? Okay, so let me go back and check. Okay, since somebody, well, this 14. Okay, 1 will go into 7 how many times? It will be 7. So it will be 7 times 2 roots of 7. And 7 is a non-radicand. It will multiply the 2 here, which is also a non-radicand. So 2 times 7 is 14. So 14 roots of 7. As for this one, it shouldn't be a problem now. We've done complex question. Okay. Is it clear now? I hope you are fine. Okay. All right. So this nature of the question, you have to be very, very careful. Okay, in math, anytime, okay, you are asked to leave your answer in a particular form, when you read a question, underline the form that you are asked to leave your answer. Other than that, if your answer is not left in that form, 1, you won't get the marks. Then 2, if the form that you are asked to leave your answer contains letters, okay, the conclusion is supposed to be done in a particular way. So very soon you will know. All right, so let's quickly go and, sorry, look at the solution to question 4a. So let's read, okay, let me check. I quite remember I swapped the questions just to, I swapped. So please, the A will be B, okay, but I didn't swap it here. So let me see if I can do the needful here before I send it to you. Other than that, the questions here, the numbers there will be different. So let me pause and do the needful, because I remember I did that for a particular reason. I didn't do the editing there. Okay, so now I've rectified, okay, the issue. So it is in the same order. Okay, so solution. So as I said, when you read questions where there is a form, underline the form. So with this question, there is a salient part to underline in math questions. Okay, so question 4. Okay, A. We need to extract what we are giving, what we are supposed to express in this form. So this is very vital information. So we have to. So giving, or you just write root of 3 plus root of 2 all over, okay, root of 3. There's an expression, so you know. Though you were not asked specifically to, okay, rationalize the denominator, you can see that what you have here, there is no denominator containing, what do you call it, a Z. Okay, and also you should know automatically, once it contains a Z in the denominator, indirectly rationalization must be in play. So here we are going to have root of 3 plus root of 2. You write it again over, okay, root of 3, then times root of 3 over root of what? Root of 3. So that gives us what? Okay, denominator, you can easily write it, and that will give you 3. Root of 3 times root of 3, that will give you 3. Then plus root of 3 times root of 2 times root of 3, and that will give us root of 6. All correct. Or originally, okay, we are supposed to end here because our answer is in a single fraction form and we can't factorize and reduce. But per the nature of the question, you cannot end here because in the question, the form, how many terms do you see there? How many terms?
2 terms.
2 terms. How many terms do you see here?
3.
I saw this coming. Okay, it's not 3. Anytime you see a single fraction, every single fraction is a term, irrespective of the numerator, denominator containing 1,000 terms or not. Once it's a single fraction, it's a term. All correct. It's the numerator that contains 2 terms and the denominator only 1 term. But the whole of this expression is a single term because of the single fraction. Safa, you get it now. So here, oops. Okay, per the nature of what we have here, we cannot end here because we need to leave our answer as what? 2 terms. But here is only 1 term. Okay, so that's why I told you, if you want you to leave your answer in a particular way, you have to split. The question directly or indirectly will tell you. So this one, the question directly is telling us that we shouldn't end this way. So we have to split. Okay, and write it as term. And you know, if you have, okay, 1,000 terms over a common term, you know what you are supposed to do if you want to split. So the partial fraction form of the single fraction will be 3 over 3, then plus what? 1 over 3 root of 6. Do you agree? Or root of 6 over 3. Is that clear? It's the same thing. Okay, however, you know this one, you can't leave it like that because you can reduce. No, this cannot be reduced. So at that point, we are going to get 1 plus what? 1 over 3 root of 6. Okay, so Prof. Gabi.
Sir, please, why did you make it 1 over 3 with 6?
Okay, so I think
Or is there another form of
writing it. I've been saying it. Okay, if I have A, B over C, I can write this as A, C, B. A over C, B. You get it? If I have...
Yes, so is it the like best form to write it?
Is it what? The best form?
Yes.
Yeah, it's the best form because of the form. Okay, you soon know. Okay, I said it even in some of the examples that we did. Okay, I think one of them, I ended up in that, okay, concluding the first one I concluded with. Okay, I remember very well. Let me see if I can get it for you. Okay, this is root of 2 on 4. Okay, but the other one I did, okay, I think 1 over 2 root of, hey, you see. You see. So I told you that you can write it, that the meaning will be the same. I said it even here, that this is the same as root of 2 over 4, which is the same as 1 over 4 root of 2. Because if I want to bring my fraction out, the coefficient is a fraction, my numerator will be 1 and the denominator will be 4. You get it? Okay, however, with this one, just for convenience sake, that we have to always write it in that form. Okay, and very soon you know, especially with our conclusion. So at this point, this is what we are going to do. We've not drawn our conclusion. So therefore, okay, root of 3 plus root of 2 all over root of 3 will be equal to, so you express it in the form. And in the form, you can see that the non-set term comes first. So my non-set term here should come first. So it's 1. Then plus my set term, which is what? 1 over 3 root of 6. However, you can't end here. You write comma, you compare, okay, and this form to your result here and attach the values of the x and y, the letters there. Very important. So if I compare comma, my x will be equal to 1. Do you agree?
Yes, please.
And if you have space here, you continue. I don't have space, so I'm coming down. And as I'm coming down, I write close to the margin. And okay, my y, you know y is the coefficient of the root of 6. Can you see that? So here, the coefficient of the root of 6, you can clearly see that it's 1 over 3. However, if someone wrote it as root of 6 over 3, the reason why I don't encourage students, usually when students are picking the coefficient, they will pick the coefficient to 1, they will leave the 3, forgetting that the 3 is also part of the coefficient. You get the point? So if you write it this way, you can clearly see what is multiplying the root of 6, and that is the 1 over 3, and you pick that as your y. Is my point well made, or you want me to come again?
Please
Please
come.
come again.
I intentionally didn't want to ask this question. Okay, anyway. Okay, so the come again part. Okay, don't worry. Okay, I'm always here for you. So this is it. Okay. As for this, up to this point, I think we all agree. Are you fine? It's just a matter of you knowing that if I have A over B, this is the same as 1 over BA. You get it? If I have 1 over 2x, okay, this is the same as what? X over 2. But if I want to make my coefficient what? Explicit, that's why I have to bring it out. So just like this, so that it will be explicit. So in this same way, this is what we can, and this is the same as root of 6 over 3. Okay, however, if you can write it that way, and you will know that the coefficient will be 1 over 3, that's okay. I usually don't get it from that perspective. So if you are writing it, you know, this is a denominator. So what will be the numerator of this one? The numerator of, okay, will be the coefficient of this, which is 1. So it will be 1 over this denominator, then the root of 6. As simple as that. Okay, so if you get this now, after writing it in the form, which is your non-said 2 terms, non-said plus a said, non-said plus a said. Okay, don't end there. Because the form that you were asked to leave it in contains letters, always compare and attach the values of the letters. So in this case, comma, if I compare my x, okay, here is this non-said term, and that is 1. My y is what is multiplying the root of x, and what is multiplying this is the same as 1 over 3 times root of x. So what is multiplying the root of x is the 1 over 3. So it means my y will be equal to 1 over 3. Is it clear now?
Yes, please.
Okay, we'll do one
Yes,
more
please.
quickly so you get there. Okay, so that will be, so we have one more to do together. So let's look at this. We are looking at what B. Okay, B, what are we giving? So we are supposed to simplify as far as, so it means indirectly, we are supposed to leave it first of all in this form. Then after that, find the value of x plus y. Okay, so the question indirectly is 2 in 1. Simplify as far as this, okay, which will contain the letters you need to compare and attach the letters before you can use it to get x plus y. So in this case, what do you've been given root of 5 plus root of 2 all over what? Over root of 10. Okay, so again, this will be equal to, you are going to rationalize. So root of 5 plus root of 2 over root of 10, you write it again. 10 times your root of 10, okay, over root of 10. Okay, so this will be equal to, my denominator will always be very easy to write. Root of 10 times root of 10, that will give me 10. Okay, root of 5 times, okay, root of 10, and that will give me root of 50. Is that clear? Then plus root of what? 2 times root of 10, that will give us root of 20. All correct?
Yes, please.
Okay, however, you know here we can't end it because you don't leave a set, even apart from the form, you don't leave a set containing, okay, which can be reduced as your final answer. So what you have here will be the same as, now we go and reduce the set, which will be 25 times 2. Okay, then plus this will be here, 4 times 5. Okay, all
Yes,
over 10. Okay, my professors, I hope you are following. You are not lost. So we know this will give us root of 25, which will give us 5. So I'll get 5 root of 2, then plus 2 root of what? 5. All over 10. Afa. Okay, so I'm going to continue here. I'm going to assume this is my next space. So in that case, I'll rule a line there. Okay, so this will be equal to, let me see if I can use this. So this will be equal to, remember, because of the form, how many terms do you see in the form? How many terms?
2.
2 terms. Okay, then now what do? We know this is a single fraction, so just a term. So we need to split this one. Okay, and that will give us what? Let's go. It will be 5, okay, root 2 over 10, or 5 over 10 root 2. Then plus, okay, 2 over 10 root 5, or 2 root 5 over 10 is the same thing. I've explained that. So this will be equal to, you know, the non-radicals can reduce. So that will give you 1 over 2 root of 2. All correct. Then plus 1 over 5, okay, root of 5. Afa.
Yes, please.
Okay, any questions at this point? Who wants me to come again? Today they are disappointing me. Okay, you know you can reduce this. Remember, you've done division. I always tell you that the points, I know I've given you all the tools, so you just have to apply it. I know the way I structure my questions. Okay, so now at this point, you know, okay, it is of this form. Please take note. Okay, let the form guide you equally to arrange. So here in the form, the root of 510 comes first, followed by the root of 2. So when you were moving from here to here, you could have swapped. Okay, but we didn't do that, so I'm going to do the swapping here. Then I'll end for the first part. Okay, so that will give me, okay, 1/5 root of 5, then plus, okay, 1/2 root of 2. Do you get my point?
No, please.
Oh, you can see that in the form, you've left it in the form, 2 fractions or 2 terms, if I'm supposed to put it that way. However, in the form, you were asked specifically to, okay, your form should have the root of 5 term being your first term and your second term being by where you've ended. Your first term is rather the root of 2 term and your second term root of 5 term. So if possible, swap so that it will conform exactly. You get it?
Yes, please.
So that's all that I did. I only rearranged just to be in this point. I said, okay, if you are mature, then you think before writing. This particular step should be out because moving from here to here, you could have done the swapping here. So this step, okay, will not attract any marks. It is this that will attract the marks because we can move from here and do the rearrangement straight away. You get the point? Okay, so
Yes,
at that
please.
point, we are more than good to go. So what do? We are going to end, okay, here. But you know, comma, okay, here, because we were asked to if simplify this, we didn't say that simplify as fast as possible. You have done that indirectly. So extract your x and y, and that will help you find whatever that you were asked to find. So what is your x? So comma, x will be equal to x is the coefficient of the root of 5, and that is 1/5. Do you agree?
Please, I thought we write that one in the conclusion.
Yes, that's why I say, you see, this question, your conclusion, you conclude for a direct question. That is, okay, so you can see that the direct question is for x plus y. Can you see that?
Yes, please.
So this is only a means to an end. But before I can find my direct question, I will need the x and the y. So at this point, I won't come and say, if the question said, okay, express this in the form this, hence find this, and it means the question directly is in 2-in-1. First of all, express it in that form. And secondly, what do? You find the value of what? X and y. I mean, x plus y, I should say. But here, because the question specifically did not ask us to leave it in this form, we can choose not to draw our conclusion there because it wasn't a direct question. It's only a means to an end. You get it?
Yes, please.
Okay.
Thank you.
You are welcome, my professor. So, and okay, your y, and someone can also write comma. Remember, I've told you in math, comma can also mean and. That's the more reason why when you are solving the equation and you are using the 0.2 tool, you should avoid using the comma because it is rather or. Okay, so, and what will be your y? Y is the coefficient of root of 2. And what do you think coefficient of root of 2 will be here? What is the coefficient of root of 2? 1/2. Okay, so at this point, we are in a comfortable lead. We can find x plus y, what you were asked to find. So I'm matured. I'll write therefore, remember, okay, x plus y, okay, will be equal to 1/5 plus 1/2. Then I will come down. Okay, and that will give me, if you want to take the LCM, you take the LCM. That will be 10. Okay, this will go here, 2, so 2, then plus this will go here, 5. So we are going to get what? 5. So that will give us what? 7/10. Remember, therefore is already here, so you've done our conclusion. Or if you don't write therefore here, the right implication here, it means you are now going to draw your conclusion. Papa.
Yes, please.
Okay. Any issues? Who wants me to go over? Okay, we thank God. So this takes us to our last, okay, set of questions. Okay, so that will be this. Okay, all right. Okay, quickly. So let's go and look at the solution to this particular question. So write the example 5. Without using tables or calculators, so it means, please, immediately you see that you hide your calculator. Okay, and tables, please, it's not a table that you are writing on, take notes. Okay, there is a table that can give you, okay, roots of 2, and I mean, the square root, the irrational numbers, they are corresponding values. Okay, so usually when you see this, it means avoid using that book as well as a calculator. But if you don't see without using table and you see only calculator, it implies. If you don't see without using calculator and you see without using table, it implies that don't use your calculator. However, okay, at a point, you can use your calculator and no one will have issues with you. Okay, so going forward, you know exactly what I mean by that. So question 5. Okay, A. What am I giving? 2 root of 2 into 6 minus 3 root of 2. Okay, then again, and okay, you've been given this. I can choose to end right end, or I can write semicolon here, then write root of 2 is equal to, that's what you've been given, 1.414. Or you can underline this in the question. Okay, later when you need it, you can go for it and use it. Okay, so what is important for you to extract is this. Okay, so this will be equal to, immediately, okay, you come and substitute directly the root of 2 here, its value here, asemwaba. Okay, because you have to avoid a situation where you will see that you will be multiplying 2 decimals, where you will be multiplying 2 decimals, because if you want to multiply 2 decimals, obviously the calculator will come in. So you can multiply a decimal and a whole number easily than multiply 2 decimals, true or false. Hello, true or false?
True.
True. So here, this is all that you need to do. Always remove the brackets. Always remove the brackets. If you remove the bracket, you realize that at a point, you will not multiply decimal, because here, when you are moving the bracket and you substitute, it will be a decimal here multiplying another decimal. Immediately you do that, M0, A0. So I'm going to expand without substitution. So if I expand, this will give me 12 root of 2. Do you agree? Then minus, this will give me 6 times 2. Do you agree? So I will simplify. This gives me 12 root of 2, then minus 12. My professors, are you there?
Yes, please.
Okay, so at this point, you can see that if you substitute root of 2, are you going to multiply 2 decimals? Will you multiply 2 decimals anywhere here? No, it will be a whole number and a decimal, so you can do that. Afa. So I will substitute my root of 2 here now. Then minus 12. Okay, Prof. Mami, yeah.
Please, how did you get the 6 multiplied by 2?
Oh, it was this one, root 2 times 3 root 2. And the non-radicals will multiply. 2 will multiply the 3, that will give you 6. And root 2 times root 2 will give you 2.
Okay.
All right. Okay, great. Okay, so now, okay, at this point, you can use your calculator. Nobody will. Okay, multiply a whole number. And so just use your calculator. Let's go. Nobody will know. So anytime you are multiplying a whole number, okay, and you can use your calculator. Only that sometimes we are smart enough to know, and I will give you the hint. Okay, so use your calculator and let's see what you are going to get. So my professors, we don't have time. Oh.
16.168.
168. Okay, then minus 12. So that gives us, again, use your calculator, no issues.
4.968.
4.96. No, it cannot be.
4.168.
No,
Okay.
Says 968.
it's
No, it
968.
cannot be 168 because you are
No, the
subtracting.
answer.
If the 12 was rather here,
Yeah, no, the 12 times
Well,
the
it's 16.968.
no, this is 968.
Yes, please.
Yes.
Okay, so this is 9. Is that it?
Yes, please.
Okay, so and your answer will be 4.968. Is that it?
Yes, please. Yes,
Okay,
please.
so you could have drawn your conclusion here. So therefore, okay, 2 root of 2 into 6, okay, minus 3 root of 2 is equal to 4.968. Afa. So it's the same thing that you will do here. Expand before you carry out your substitution. As simple as that. Okay, so unfortunately, okay, so that's where we got to. In our next meeting, we'll be looking at solved past questions or likely exam questions. Okay, God willing, tomorrow. And we'll bring down, okay, the curtains on, okay, said. Okay, however, so thank you very much. If you don't have any question, God bless us once again. And I'm really grateful for making the class interactive. Okay, so have a lovely day.